Hey guys, welcome back. All right, so last time we talked about how limits are allowed to equal positive or negative infinity. Today we're going to talk about how limits are allowed to approach positive or negative infinity. Here's the basic idea. Let's look at a couple graphs. Now this function here is definitely not the above function in the limit. You'll recognize this function as y equals 1 over x. We're just looking at the basic concept of a limit approaching infinity. And when we do, you'll see that as our x gets bigger and bigger and bigger, the y value gets closer and closer and closer to a y value of 0. As the limit approaches infinity, the y value that it's approaching is 0. Now it doesn't actually ever touch 0, but it's getting closer and closer and closer to 0. Similarly, as the function approaches negative infinity, as the x values go forever to the left, the y value gets closer and closer and closer to a y value of 0. The function is approaching 0 as x goes to positive infinity and as x goes to negative infinity. We'll talk about how that happens in just a minute, but for now, understand the concept of going forever to the right and forever to the left. Take a look at another graph. This time we're looking at the function y equals 1 over x squared plus 3. And looking at the graph, you can see our x-axis down here and our y-axis up here. So looking at the pretty picture, I'm wondering, as the x values go forever to the right, as the x values go to positive infinity, what y value is the graph approaching? So if you look at the y values as you go forever to the right, you see that the function kind of levels out. Now again, we're never actually going to touch that level. There's a horizontal asymptote there, but you see that the y value we're approaching is 3. If we go to the left, if our x values approach negative infinity, looking at the y values as we get closer and closer to negative infinity, forever to the left, you see that we're never going to touch that horizontal asymptote, but we do approach a y value of 3. Let's take a look at another function. This time we're looking at the function y equals x cubed. And again, as x goes forever to the right, as x gets bigger and bigger and bigger, as x approaches infinity, we can jump on the function and follow the y values. And the question is, what y value are we approaching as x gets forever bigger? The y value goes up and up and up and up, forever up. The y value is going to infinity. The y value isn't approaching any one particular value. It's just going up forever and ever. Now as we look to negative infinity, as our x value goes to the left forever and ever, the y value goes down forever and ever. Our y value, as x approaches negative infinity, is negative infinity. So the limit as x approaches positive infinity is positive infinity. And the limit as x approaches negative infinity is negative infinity. So when we're trying to figure out the limit as x approaches positive infinity or negative infinity, the basic idea is the question, does the function have a horizontal asymptote? If the function has a horizontal asymptote, then that's the y value that we're approaching. We're going to be approaching the y value of the horizontal asymptote. If the function doesn't have a horizontal asymptote, then we're going up forever or we're going down forever. It just depends on the graph. So the answer to a limit as x approaches positive infinity or negative infinity can be a number, and just to be clear, that means it can be 0. 0 is just a number. Or it can be positive infinity, or it can be negative infinity. So the question that needs to be answered for each function is, does this function have a horizontal asymptote? And if it does, you find the horizontal asymptote, and that's your answer. Let's talk about how we're going to do that. Now think back to when you learned about rational functions, something like this. To sketch this function, our first step was to find the domain. After finding the domain, we would find the type of discontinuity and where it occurred. Our third step was to find the horizontal asymptote. And if you can remember this, the way we found a horizontal asymptote was to keep the highest power on top, the highest power on bottom. So in this case, we would have y equals x squared over 2x squared, and then we would reduce the fraction. In this case, we get 1/2, which means we have a horizontal asymptote at y equals 1/2. If the function was bottom heavy and we had something like x squared over 2x cubed, you'd cancel your x's, we'd have 1 over 2x, and if you ended up with an x on the bottom, that meant that there was a horizontal asymptote at y equals 0. If the function was top heavy, cancel the x's, and that meant that there was no horizontal asymptote. The first problem we looked at was the limit of this function as x approaches infinity. I'm going to show you my way to evaluate the limit as x goes to infinity or negative infinity. I'm sure I'm not the only teacher that does it this way, but it's quite different than the book way, and we'll get into that too. And just in case you're concerned, my way works every time. I use the exact same logic for finding a horizontal asymptote. We're going to keep the highest power on top and the highest power on bottom. That gives us the limit as x goes to infinity of x squared over 2x squared. Then we can reduce our fraction. That leaves us with a 1/2 left, and the limit of a constant is just the constant. Our answer is 1/2, which makes total sense considering that there's a horizontal asymptote in the function, and we're going to be getting closer and closer to that value as we go forever to the right and forever to the left. The book's way of approaching the same problem is quite a bit more complicated. The real mathematical way to approach these problems is to look at the numerator and the denominator and find the highest power for the whole function. In this case, the highest power is in x squared. So from there, we multiply the top by 1 over x squared, and we multiply the bottom by 1 over x squared. 1 over x squared over 1 over x squared is just a fancy version of 1, so we're not really changing anything. But when we do that, we multiply that term through, and we get the limit as x goes to infinity of x squared plus 5x plus 2 over x squared all over 2x squared plus 3x over x squared. Now we separate those fractions, and we get the limit as x goes to infinity of x squared over x squared plus 5x over x squared plus 2 over x squared all over 2x squared over x squared plus 3x over x squared. Now we run through and we reduce all of our fractions. X squared over x squared gives us 1. Then we have 5 over x. 2 over x squared doesn't reduce. Then we have 2. And then x over x squared reduces to 3 over x. Cleaning that up a bit, we have the limit as x approaches infinity of 1 plus 5 over x plus 2 over x squared all over 2 plus 3 over x. At this point, you can substitute in the infinity value. And we get 1 plus 5 over infinity plus 2 over infinity squared all over 2 plus 3 over infinity. And here's the idea that you need to understand about limits. A limit is an approach, as we've talked about several times. A limit is just an approach. So think about this idea. Let's say I was going to share my pizza with you, and I gave you half of my pizza. That's a good amount of pizza. But maybe I only give you 1/10 of my pizza. It's still a slice. At least I'm giving you a slice of pizza. Maybe I'm only giving you 1/20th of my pizza. That's maybe like half a slice of pizza, which, I mean, it's not much, but it's still something. But what if I gave you only 1/100th of my pizza? Not much pizza. Or maybe 1/1000th of my pizza. What if I gave you 1/1,000,000th of my pizza? That's basically no pizza at all. So what if I gave you 1/infinitieth of my pizza? How much pizza are you really getting? You're essentially getting no pizza at all. And in the world of limits, a value of 1 over infinity is essentially a 0 value. Basically, you're getting nothing because we are approaching the y value of 0. So when we look back at the limit we were dealing with, 5 over infinity is essentially 0. That's really little pizza. If I give you 5/infinitieths of a pizza, that's basically 0 pizza. And same with 2 over infinity squared. You're getting no pizza. Same with 3 over infinity. You're getting no pizza. And once we realize that each of those reduce down to 0, you see that you are left with 1/2. The limit of this function as x approaches infinity is 1/2. And this is a good, sound mathematical way to approach the problem, but it's a whole lot quicker to just think of it as a horizontal asymptote and treat the function that way. If you can remember back to when we first learned rational functions, I said that we keep the highest power on top, highest power on bottom, and we could simply ignore all the other terms, and there was a reason, and I promised I would tell you that reason. Well, girls and guys, here we are. I am telling you that reason right now. The reason we can keep just the highest power on top and just the highest power on bottom is because going through the limit process, all the other terms reduce down to 0. You end up being left with just the highest power on the top and the bottom anyway. It's all about limits, but we weren't ready to talk about that back then. So we're talking about it now. There you go. We keep the highest power on top, highest power on bottom, because with limits approaching infinity, all the other powers disappear. So let's take a look at another problem. It's very similar to the problem that we were just working with, except we have a 2x cubed on the bottom instead of a 2x squared. So let's evaluate the limit. To evaluate the limit, we're going to keep the highest power on top, the highest power on bottom. That gives us the limit as x approaches infinity of x squared over 2x cubed. Then we reduce our fraction. We now have the limit as x approaches infinity of 1 over 2x. After we've reduced our fraction, we can go ahead and substitute in the infinity value. So we have 1 over 2 infinity. And in the world of limits, if I gave you 1 over 2 infinitieths of my pizza, how much pizza are you really getting? You're getting 0 pizza. You're basically getting nothing. And the answer to this limit is 0. And it makes sense because thinking back, what we have is a bottom-heavy function. We always knew that if we were left with an x value on the bottom, the horizontal asymptote was 0. And this is why, because in the world of limits, the fraction gets so small, it's approaching 0. Let's go again. Again, it's a very similar function, except this time I have an x cubed on top. Let's evaluate the limit. We're going to keep the highest power on top, highest power on bottom. That gives us the limit as x approaches infinity of x cubed over 2x squared. After keeping the highest powers, we reduce our fraction. We have the limit as x approaches infinity of x over 2. And once we've reduced the fraction, we go ahead and substitute in the infinity value. So we get infinity over 2. Which can be written as 1/2 of infinity. And in the world of infinities, if we're going forever and ever and ever and ever and ever, if I say, well, you know what, chop that in half, does it really change anything? No, we're still going forever. We're still approaching infinity. And that means this is one of those functions that goes up and up and up forever. And again, if you think about it, what we have is a top-heavy function, and we've always known that if our function was top-heavy, there was no horizontal asymptote. And the reason there's no horizontal asymptote is because the function is going up and up and up forever. Now, if this same limit had been approaching negative infinity, at this point we would have x approaches negative infinity, which would take us to negative infinity over 2. So we would have negative 1/2 infinity, which would be negative infinity. So the process still plays out the exact same way. We just have a little negative that gets thrown in there. If it had been a negative infinity in the previous problem, we would have 1 over 2 times negative infinity, which is 1 over negative 2 infinitieth, which is still basically no pizza. Let's try a few problems, and after I give you each one, pause the video and see if you can come up with the right answer before I show you how to do it. Find the limit as x goes to infinity of 3x plus 5 over 7x minus 2. We're going to keep the highest power on top, highest power on bottom. That gives us the limit as x goes to infinity of 3x over 7x. Reduce the fraction, and I know that the limit of a constant is just the constant. My answer is 3/7. Try this one. Evaluate the limit as x goes to infinity of 5x to the 7 minus 3x over negative 3x squared plus 16x to the 6th. I tried to get tricky with this one. The highest power on top is 5x to the 7. The highest power on bottom is 16x to the 6th. And so what we have is the limit as x goes to infinity of 5x to the 7 over 16x to the 6. Reduce the fraction. That gives us the limit as x goes to infinity of 5x over 16. We can go ahead and plug in the infinity, and we get 5 infinity over 16, which is 5/16 of infinity. But if we're going forever and ever, does multiplying by 5/16 really matter? No, we're still approaching infinity. Try this one. Evaluate the limit as x approaches negative infinity of 5x to the 6 minus 3x over 16x to the 7 minus 3x squared. Find the highest power on top, the highest power on bottom. Reduce the fraction. And if there are any variables left, you can go ahead and plug in your infinity. So we have 5 over 16 times negative infinity. That's negative 5 over 16 infinitieths. And if I was to give you 5/16 infinitieths of my pizza, I'm basically giving you 0 pizza. You've got nothing. Now, the fact that it's negative doesn't change anything. We're still approaching 0. We're just technically approaching 0 from the negative side. The limit is still 0, though. Try this. Evaluate the limit of the function. I find the highest power on top and the highest power on bottom, and I rewrite the limit. So I have the limit as x approaches infinity of negative 3x to the 10 over 33x to the 10. Reduce the fraction, and I end up with negative 1/11. And we know that the limit of a constant is just the constant. Let's try one more. Let's find the limit as x approaches negative infinity of 1 over x plus 3 squared. This one's a little bit more interesting in that you need to think through the bottom term. You can do this a couple ways. You can decide to actually FOIL this term out all the way, or you can look at just the highest term and multiply that out. The other way you can think this through is to eliminate all but the highest power, and then you would be left with the x squared. However you think through it, the highest power on top is 1, and the highest power on bottom is x squared. So rewriting this limit, I have the limit as x approaches negative infinity of 1 over x squared. There's nothing to reduce, so I'm going to go ahead and substitute in my negative infinity value. So that gives me 1 over infinity squared, because the negative squares away. And if I'm giving you 1 over infinity squareds of my pizza, how much pizza are you getting? You're basically getting 0 pizza. Now I know I said the last one was the last one, but I want to do just one more. Sorry. Let's go with the limit as x approaches infinity of x squared plus 2x plus 5 squared over x minus 9 cubed. And you can think through this however you want. You can square out the top term if you want to. You can cube out the bottom term if you want to. Or you can eliminate all but the highest power on both the top and the bottom and see that you're left with x squared, squared, and x cubed. And rewriting my limit, I get the limit as x approaches infinity of x to the 4 over x cubed. Reducing my fraction, I get the limit as x approaches infinity of x. Substituting in my infinite value, I get just infinity. And that's all there is. The answer is infinity. All right, guys, I hope this makes sense. If you have any questions, let me know. Have a great day.